So we can solve this, and then we can see what's happening with our inside and outside restrictions here. Okay, so first of all, let's just solve this. So we're going to solve this by squaring both sides. Okay, so we're going to square both sides of this equation. So we end up with 2x plus 1 equals x squared minus 2x plus 1. It's a quadratic equation, so make it equal to 0. X squared minus 4x, and then the 1's cancel out. And actually I can factor this and solve, so I'm going to factor. So I get x is equal to 0. The other factor is x is equal to positive 4. Okay, so I get two solutions, okay, algebraically. Remember that I really need to check both solutions. Okay, so when I check both solutions, well, let's actually check by just graphing this. Okay, so what I'm going to do is I'm going to graph to the left side and right side of the equation. So we could check it by just plugging it in. But here we're going to check this by graphing the left side versus the right side and see what happens. Okay, so x minus 1 is going to be a linear function that kind of looks like that, straight line. Okay, and then we're going to have this here, the square root of 2x plus 1 is going to look like this. So when we look at the intersection of that, there is one solution here. In fact, this solution, if you take a look at that solution, is at x equals 4. So that's a perfectly valid solution. So I'm just going to highlight that. Okay, so there's my solution. There's my x equals 4 solution. Now, the x equals 0 solution doesn't show up. Well, why doesn't it show up? Well, let's plug it in and see if it actually works. So if I plug in 0, I get square root of 1 is 1 equals 0 minus 1 is negative 1. So we get 1 equals negative 1. That doesn't work. Okay, so I'm just going to show the test here. So this is my check. Okay, so check x equals 0, and we'll see that it doesn't work. So it's square root 2 times 0 plus 1 equals 0 minus 1. So we get square root 1 is equal to negative 1. Well, that's not true. Okay, that's extraneous. So there's our extraneous solution. Okay, so why is it extraneous? Well, again, the reason why it's extraneous is because when we square both sides of this equation, what ends up happening is we end up introducing the second half of the bottom half of the parabola, which doesn't exist. And notice that there's my extraneous x equals 0 solution. Okay, that's the one that doesn't exist. So just cross that out. But algebraically, remember that when we square both sides, it's possible that we get extraneous solutions because of this issue. Okay, and we can see that. We can see that from either testing. We can see that on the graph it doesn't show up. So these are different ways that we can confirm this. So checking by testing, by plugging it in. We can check by graphing if that's possible, if you have that option. And we can see that this part of the graph doesn't show up, so that solution must be extraneous. The third is we actually can show this using restrictions. Okay, so I'm going to do restrictions in green here. The restrictions are so my restrictions were x must be greater than or equal to negative 1/2. Okay. The other restriction is here. That's my inside restriction. My outside restriction is x must be greater than or equal to 1. Okay, because this is my from here. That's my outside restriction. Well, 4 passes both of these restrictions. It's bigger than negative 1/2, bigger than 1. But 0 does not pass that restriction. It is not bigger than 1. And so it fails from the domain restrictions of the x. So that would be the third way we can confirm it. Okay, so I'm going to put 3 here. Okay, this is going to be our first way, and these should be the priority as well. The easiest way to test for extraneous roots is just by checking. Another easy way is by graphing. The third way, which is one that we probably want to just avoid, but we should know about it, is that if we check the restrictions, our solution has to pass the restrictions as well. And so there's 3 different ways we can actually confirm extraneous solutions. So by stating the domain, in fact maybe I should put that here, by stating the domain we can actually determine whether we have extraneous solutions or not.